All right, guys, welcome to another episode of Cuda Education. Vulkan is the gift that keeps on giving. Um, Santa Claus needs a consultation with Vulkan because once I get my Christmas gifts, it only lasts for like maybe a couple of weeks to a month, right? But with this Vulkan stuff, every day you wake up, you get a new gift. So the gift for today is a thing called specialization constant. Okay. Now I didn't know what this was about. I didn't know where this came from. I was like, what is this? I thought I was done with compute headless, but every time I feel like I could move on, it pulls me back in. I'm like, what is this specialization constant and what it's about? All right, so just so you know, I've sort of modified the way how the application runs so that basically it's going to it's going to output the value that I have here for the specialization content constant, right? So basically you see 32, 32, 32 everywhere, right? um, Now this specialization constant, it's a way for you to pass in values to the shader during pipeline creation without having to recompile the shader. I'll repeat. You could pass in values for to the shader at pipeline creation um, without having to recompile or do anything with the shader. The reason I say that is because as you guys um, as you guys know by now, every time you change the shader, every time you change something in your shader, you have to recompile it into spare V format. Okay, you have to recompile it into spare V format. Um, but this specialization constant gives you a way to affect how the shader runs. Um, Basically, from the CPU side, right? So you could affect how the shader runs uh, based on what value you set here, right? So you're not hard coding a value into the shader, right? You're not hard coding a value into the shader. This value here is dictating what happens in the shader. Okay, so this is from CPU side all the way to the shader on the GPU. So you can affect how the shader runs. So like for example, this text index is greater than equal buffer elements. This test will be directly affected by what value you put here. Okay. Now, as I said, I hacked it a little bit. I changed the shader code directly because I wanted to display the value that I have here. So again, when I run it, I basically get the value that I have here. Okay. So, and I didn't recompile. I didn't recompile the shader or anything. So if I rerun my code with this new value, you will see that the shader outputs the new value that I have here. Okay. Now I changed it to 765 for a reason, because up here is where we bring in the value, we bring in buffer elements from here. Okay, so this value is passed in. Um, I'm gonna assume the signature. The signature. Go to definition. Um, yeah, I'm not going to actually get into the semantics. VK specialization map entry, VK specialization info. Um, I'm trying to figure out where this constant ID. Okay, so this constant ID, I assume, matches with what we have here. Okay, so the reason I go through all of that is because the reason I changed it to 765 is because here we bring in the value, but notice that we have 32 here. This is just the fallback value, right? This is just the fallback value. So if buffer elements for whatever reason isn't passed in or whatever, because remember now your shader down here in main is expecting this buffer elements variable. So this is a fallback in case you didn't pass in the value. Okay. So if I do this to like 987, if I change this again to 987 and I rerun the application, basically 987 shows up. Okay. Um, Now I don't really, I've tried to like display or do the fallback value, but like if I comment out the specialization constant, um, basically I get a value, but it's like I don't know if I have to do some formatting or whatever, but I get this. It's all the same number, but it ain't 32, right? But that's a fallback value. So even when I don't pass in a value, um, I still get what it said validation. Oh, this is interesting. It's greater than data type for size of each element must be less than or equal to blah 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 blah. So yeah, it's probably something I'm doing on this side where I'm not. Um, can I just pass in a blank variable and then it will do what I expect it to do? Yeah, I don't know, man. But basically, if I pass in a value, everything runs as expected, right? So I modified, as I said, I modified the script so that it just shows the buffer elements, right? This is not the original code for compute headless, right? Um, but what I'm trying to show you is that you could affect the behavior. Um, Specialization constants can remove whole code paths at compile time. So while you're compiling and basically preparing the pipeline and running your code, you can affect how a shader behaves because you could pass in this value here, um, from CPU side. Now, me being me, I'm like, oh, I could pass in data to the shader, to the GPU through the shader. Why don't I try and pass all 32 values from the CPU side? Why don't I try and pass in all of this stuff from the CPU? Because I'm basically I create 32 numbers on the CPU side, and then I use a staging buffer to transfer it over to the GPU. I'm like, why can't I do that? And then I basically realized that no, you can't do that because for a variety of reasons, it's not designed for that. Um, but it is designed. Specializations constants can remove whole code paths at compile time. So you could dynamically change this, um, and you could change this and create multiple pipelines and save it in pipeline cache. Okay, that's a whole nother discussion for another episode. But what people do is you could create, so say you have a buffer elements of 8, a buffer elements of 16, a buffer elements of 32, and for each one of those buffer elements, you create a special pipeline. You create a pipeline and you save that pipeline. So the next time you need to run this stuff, the pipeline is already saved and like your application can run faster, right? This is a discussion for another episode, but we have this pipeline cache conversation, right? Which I'm not going to get into right now, but basically, for each one of your buffer elements, you could do configuration and stuff. Um, Buffer, this is close to like defined values, right? So we have defined values, you know, we have defined values. Where's defined? Do we have a defined value here? No, we don't. But we have defined values. It's like a constant, like hashtag define, right? Um, yeah, specialization constants are compile time constants at pipeline creation time. You don't need to rebuild the shader file, you just rebuild the pipeline or create another pipeline, right? So you could change shader behavior without recompiling spare V and without using uniforms or constant push constants. Okay, so that's specialization constants for you guys. Let me put this back to what it was before. So this is 32, right? And then also I have to change back my shader code to the original. So now, because I'm changing back my shader code, right, I do have to recompile the shader so that we get back the correct spare V format, right? So now when I run my code, I just compiled already. So now when I run my code, it gives me what I expect, right? The thing is that you know if I change this to 8 now, right, and I just run my code regularly, we're gonna get different behavior on the so we get 0 1. 0 and 1 is 1, 1 and 1 is 2, 2 and 1 is 3, 3 and 2 is 5, 5 and 3 is 8, 8 and 5 is 13. But then notice that from here on out we get a different behavior. We get a reset, which is something involved with the actual code and stuff. But basically we're able to effect change, just like change on the shader behavior just by changing this value here, right? I haven't touched the shader, I haven't recompiled, I haven't done anything like that. If I do it at 16, 1, 2, 3, 4, 5, 6. So at 16, okay, so at 16, notice that there's this guy, and then it resets again here, right? I'm not going to get into why that is. It has to do with this stuff and blah blah blah, but I'm not going to get into that, right? But you see that I'm able to effect change on the shader without having to recompile the shader, basically doing it at compile time of the pipeline. And again, I could make multiple versions. I could do a pipeline with 32, do a pipeline with 8, do a pipeline with 16, do a pipeline with 20, you know, and I have multiple pipelines now that's in pipeline cache that I could then run as I like, and effectively I change the configuration of the shader, because as you can see here, um, this buffer elements is changing the behavior of. So if index is greater than or equal to buffer elements, I just return immediately. Otherwise, I do this, you know. Anyway, guys, as I said, Vulkan is the gift that keeps on giving. You guys gonna pony up some money for Santa Claus so you could get a free consultation from Vulkan? It's a serious question. Okay, it's a gift that keeps on giving. I do want to get into pipeline cache, but yeah, I need more time on that. But the whole idea with pipeline caches is that you could save these pipelines to disk, and therefore you save on when you want to run the application again, you could just pull the specific pipeline that you want that does what you want, and it makes the application run more efficiently. I mean, obviously for what we're doing it's trivial, but if you have pipelines that has a lot going on and stuff, you will want to be able to take advantage of the pipeline cache. But you know that's a topic for another day. Specialization constants, guys. So in your time, look up VK specialization map entry and VK specialization info. Um, uh, I'm trying to see, is this a standalone or is it passed in? I'm trying to see. Uh, I'm trying to see where. Yeah, I'll probably have to revisit this again, but huh. Let's see something. Okay, here. So this guy here is where specialization. Okay, so it's being passed in. Um, it's being passed into the shader stage, the compute shader stage. Because I was like, okay, we create these variables and stuff, but where is it being consumed? But it's being consumed right here, right? And that gets passed into compute pipeline create info stage. Okay. Okay. All right. So we do all this stuff here. So that's it. That's it, guys. We got it. We do all this stuff here, right? And we pass this in to the state, the shader stage dot p specialization info. We pass it in here, and now shader stage has the ball, right? And shader stage basically goes to shader module. No, no, it doesn't. And then shader stage basically goes into compute pipeline create info, right? So again, let's start. Let's start from scratch. We do our specialization map entry and specialization info stuff here. That gets passed into shader stage dot p specialization info, right? That that shader stage stuff gets passed into compute pipeline create info dot stage, and then compute pipeline create info gets passed into vk create compute pipelines. All right, so we get it, right, guys? Bam, 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 and bam. Right? You kind of always want to see just syntax wise how the thing is glued together. Because I'm like, all right, this stuff is up here, but how do we actually get to the pipeline? But that's how we get to it. All right. I mean, obviously these parameters and signatures and stuff, I'm not going to get into that right now, but this is how we are now able to get on the shader side this. And we have our fallback value, and we're able to effect change on the shader behavior based on this. Um, right, with specialization constants, a different value usually produces a different compiled variant, likely a different cached entry. Okay? Um, yeah, right. Specialization constants are for small compile time configuration, not bulk runtime data. Um, they're meant for small configuration values, not bulk arrays. Yeah, that was me trying to figure out. I wanted to figure out if I could smash. I wanted to figure out if I could smash all these 32 values into the specialization constant and just get them to the shader, but you know, I had to ask the question, guys. I had to ask the question. Um, let's see. Yeah, and apparently with specialization constants, the performance is optimal. Anyway, guys, if you want to be able to run these examples on your machine, you need to get tutorial number 1 and tutorial number 13. Tutorial number 1 is installing the Vulkan SDK on a Windows-based machine with a Vulkan-capable GPU. Tutorial number 13 is installing a bunch of examples, including this one. If you want to be able to run ray tracing examples, right? So it's a bunch of examples, but if you want to run the ray tracing examples, you have to make sure that your GPU is also ray tracing capable. So it not only has to be Vulkan capable, but it also has to be ray tracing capable. For NVIDIA cards, that's the RTX series and greater. Don't know about the other cards. Don't know about AMD and Intel. Okay. Also, guys, on my channel, I have some great videos on. I have some great videos on talking about indirect rendering and BVH, bounding volume hierarchy. Um, it was a discussion on Gamers Nexus with with a guy, a GPU engineer at Intel, Tom Peterson, and he talks about a lot of the things that we have been discussing here. So he talks about indirect rendering, and he talks about the BVH and how optimizing those tasks, intersection testing and all that stuff, optimizing those tasks helps with getting better frame rates for the new generation of Intel GPUs. So you know, it's like the previous video to this one, I think. And then there's another in that discussion. There's also another link to um, a factory tour of an Intel GPU. Um, it was like a add-in card, AIC partner or whatever, where basically they're going through the manufacturing of a GPU, right? The actual machines that are doing all the stuff, laying out all the chips and everything. So it's really cool stuff, guys. Really cool stuff. So I strongly recommend you guys to get involved. Get tutorial number 1. Get tutorial number 13. Start down the road of learning Vulkan for 2026. Okay, it's a lot of, as I said, Vulkan is a gift that keeps on giving, but it is excellent knowledge. Okay, thank you for watching. Have a great day.